So we were talking about Butterworth approximation. But before that, like I forgot to tell you this thing last time. But this is the right time because this was the question raised by Pius. So yes. So there are few things that because I studied one more time and I found out op amp has no current go inside, but op amp can produce a current which can go there. This is one important note. So we can remove unwanted things. So in that case, if you are looking at the current, forget about this. This current and this current will be same, but the current flowing through Z3 and Z4 will not be same because there might be current added by this op amp. However, the current flowing through Z2 and Z3 will be same. So IZ2 will be equal to IZ3. Similarly, IZ4 is equal to IZ5. The reason is the current cannot go inside, but this op amp can produce a current. And similarly, you can find out the current flowing through this branch and you can find out Zin divided by Ix. So the current flowing through this one is equal to Vx by Z5. The reason is this node number 1, 2, 3 and 5 are equal to 2, 1, 3 and 5 are equal to Vx. V1 equal to V3 is equal to V5 is equal to Vx. So the current flowing through this impedance will be Vx by Z5. And voltage here V4 is equal to Vx plus current flowing through this impedance times Z5. Sorry, Z4. And that current is equal to Vx by Z5. Now, you can find out the current flowing through Z2 or Z3. Let's say we can find out the current flowing through Z3, which is equal to how much? Yes, Ashwarya. So we reached till here. I know what is the voltage V4 and I know what is the current flowing through Z4 and Z5. In op amp there is no current is flowing, but this op amp can give the current, right? So because of that there will be some like different current than what is here. Of course it will be combination of these two, but we can find out from the KCL which says that Vx minus V4 divided by Z3 is equal to IZ3 and same as Z2 also, because this current cannot go inside, so both the currents will be same. Yes, so you can find out the current flowing through this one. Sorry, oh, Vx minus V4. Once you have this current, you can find out that this current is already is equal to IZ3 or IZ2, right? We already know what is V4. V4 is Vx by Z5 times Z4 divided by Z3. So this will give me Vx by Z3 times Z5 times Z4. That's the current. IZ3 equal to IZ2. If I know the current from here, these two, I can find out what is V2. V2 is nothing but V2 is what? By the way, V2 is equal to Vx. Directly you can see here it's Vx plus IZ2 times Z2. Yeah. So you can replace IZ2 from here and you can find out V2. Once you find out V2, the current flowing through this one, which is Ix, can be found out. And Ix is equal to V1, which is Vx actually, Vx minus V2 divided by Z1 is equal to Ix. Now V2 you can get it from here, you can keep the replace here and you can find out Ix in terms of rest of the things. And then you have to find out Vx by Ix at that. Whatever Vx by Ix you can find out, that is the input impedance. And that input impedance will be, in this case, Z1, Z3 divided by Z2, Z4. I forgot the exact formula, but it has to be similar to that. Do you want to solve right now? Right? Its solution is given in book, but I went through it yesterday. Actually, on Tuesday, I forgot to discuss that. Okay. So now there is no problem, right, on such op-amp configuration. But before moving to that, one more thing I want to tell you. There is something called lossy normal integrator, and there is something called lossy integrator. So what is the difference between these two, by the way? Parasitic resistance will be there. Okay, before this, let's recall if there is an inductor and there is a capacitor. But these kind of things are only possible on paper. You cannot have purely reactive circuit. We understand what is reactance and resistance part. Like all the imaginary whatever is multiply with iota, we are going to call that one as reactance, right? So this is not possible. So in reality, inductor will have some resistance. So where it will be, in series or in parallel? And similar to capacitor, it will be in series or parallel. But do we know the reason for this one? Why do you think it will be in series and it will be in parallel here? Okay, yeah, that's true. You are saying that this is SL, the impedance. So if you are keeping something with plus, then it will change the value of impedance. In this case, to make this something in parallel, you have to convert this admittance to impedance to admittance. So it will be, to make such, like if I am doing this, it's not making more impact than if I am doing this. And just to do that, I need to keep that in parallel so that it will give the impact. So this will be going to give you more impact. So we are looking at a worst case analysis. So these inductors and capacitors are known as lossy inductor and lossy capacitors. So now next part is, if it is lossy tank, this is normal tank where you have inductor and capacitor. If you want to make it lossy tank, you can make such things. And this is also the reason why you have studied such kind of circuit in your previous study, maybe in school time, RLC in parallel, LC in parallel, right? So this is also fine. Now the next part is, let's come to the level at the integrator. If I am keeping resistance here and a capacitor here, and in the case of lossy integrator, if I am doing same thing, but the only difference will be I am going to add one small resistance in parallel. This is V in, this is V in, V out, RC. So what is the transfer function? Let's call this one R1, R2, R2. So what is the transfer function in the first case? V out by V in, 1 by SCR. Okay. What about this one? Is it correct or have I made any mistake? If no, then what I want to tell you, if in case you have to implement a circuit where it's 1 by S, then you have to use an ideal integrator, although still it's very difficult to realize in real world. But if in equation you are finding such a thing, then you have to follow just RNC. But if in yours something like this, or let's rewrite it like this, right? So 1 by SA plus S divided by A plus 1 times alpha can be realized using first part as lossy integrator and second part as inverting or non-inverting amplifier, right? Is it difficult or you can follow it? Yeah, sure. Okay, so this was only one thing which, by the way, this was one of the example where some Z1 Z2 has been replaced with resistance and capacitance, and you will get as I told you, like it has to be Ry times Ry divided by Ry times 1 by Cs times Rx, I believe. That should be the input impedance, and that will give me term where Laplace operator will be multiplied, and this thing will give me the inductor value. So that's why we are doing this. So on chip inductor can be realized using this kind of setup. Yes. Yeah. Impedance. Yes. What resistance? But you can ask me. Not a problem. So as I told you, I need to look at the. So final answer says that Z1 Z3 divided by Z1 Z3 divided by Z2 Z4 times Z5, right? So now this is resistance, right? So Z1 is Ry, Z3 is Ry, Z2 is 1 by Cs times Ry times Rx. So this will be Ry times Rx times C, right? So this way you can implement an inductor. Other than that, our main goal for making such circuits are to make filters. So various kinds of filters are needed. So this is the like topic which is always required, even if like this electrical engineering will be removed and maybe some different engineering will be coming, then also one has to understand filter. This is the most important part, and it will be used everywhere. It might be digital, it might be analog. So for that there are some approximations came into the picture. Those approximations are Butterworth, Chebyshev. So these two are in your syllabus, by the way. Third one and fourth one, if you are going to study different topic, then elliptic and basal filter you are going to study. So in these two, Butterworth has maximally flat response in passband as well as stopband. I believe you don't have doubt in what is passband, stopband, and roll off. Yes or no? So here roll off might be poor. Then if you are looking at all the its all pole transfer function, it might be normalized to center frequency which you need omega 0. All the values are coming exactly on unit circle, and all the pole values are apart from each other by 2k minus 1 pi by 2n, where k is equal to 1 to n. Right? So it would be like this. As many number, you will have only poles, and it will be exactly on unit circle. But if you are not normalizing to omega 0, you can see here circle's radius will be actually omega 0, right? So it's up to you how you are defining the equation, and this will give you a better answer. Now Chebyshev is the next approximation given by Chebyshev. In that there are two kinds of, by the way, approximation. One says that the response will look like this one. So here you will have some delta error. Let's say this is 1 minus delta p, and here it's delta s. This will be omega p and this will be omega s. Omega p is passband frequency and omega s is stopband frequency. Your answer might look like so depending on order you will see something. By the way, note that I am not starting from 0 or 1. There is some specific reason, that's why I have not started. It's depending on order and depending on some equations. So if it is Chebyshev approximation, then your passband, sorry, stop band is monotonous and your pass band having ripples but having equal equal value of amplitude. So this is also known as equiripple passband. So that is achieved by Chebyshev approximation. But there is one more variant of Chebyshev which is known as inverse Chebyshev. That will give you exactly the opposite effect, where you will have equiripple in stop band and monotonous response in pass band, right? So this is what going to happen. So this was just thing, and for that Chebyshev has given some equation. Let's look at that equation. So similar to what Butterworth has given, Butterworth has given that it's 1 plus omega by omega 0 raised to 2n, right? This was the thing given by Butterworth, and this was giving us the answers that all the poles are coming on unit circle. However, if you are talking about Chebyshev, there are some new terms came. New terms are epsilon and Cn square. By the way, this is not Cn square times omega by omega 0. It's combined together and there is one Chebyshev function. Which is defined in terms of omega and omega 0. Now, you already know that what is omega 0. Omega 0 is the 3 dB frequency. However, in this case, unlike Butterworth filter, you are not going to see that it's going to pass only through 3 dB. It may be passing through different thing, something like that. So it depends, but it will be passing through 1 minus delta p, and that delta p is not equal to 3 dB. 3 dB might be somewhere else, right? You can find out, and its derivation may take only one like it will take one lecture, so I'm not going through it. Even in your book it's not given, because considering the fact that we are studying network and your understanding of these approximations has to be given, and as for your lecture like organization, it is written that I have to teach filter in 2 lectures with all these topics. So it's not possible, right? Because if I'm just telling you that this is Butterworth Chebyshev, then that will not be useful. Little bit of mathematics might be useful to understand the filter response. So Chebyshev has given this function, and that function are having like Cn omega by omega 0 is equal to cos n cos inverse x. Is it correct? Yeah. The x is omega by omega 0. When omega by omega 0 is less than 1 or maybe less than pass band. When I am saying this omega is less than omega 0, you are in pass band. And similar to this, it has been given cos in terms of hyperbola, cos hyperbolic and cos hyperbolic inverse omega by omega 0. When omega is greater than omega 0 and you are in stop band, right? So let's assume that, by the way, because of this hyperbolic, you can see that it will be always monotonous. The most difficult part is the first part, where you need to find out how these ripples are being created. So just for, let's say, for the first part, when you are in pass band, if I want to find out C0 omega by omega 0. What will be the value? If C0 omega by omega 0, I need to find out. Means I need to replace n with 0 and n is order of the system. So what will be the answer? 1. Similarly, if I want to find out C1 at omega by omega 0, what I am going to see? Omega by omega naught. Excellent. You can even, okay. We are not going into other variable. So now what is going to happen at C2 omega by omega naught? 2 omega square by omega naught square minus 1. Very nice. What about this one? So you have to solve for cos cube. Okay. So can you write down this? So these are all these, like if you are good at trigonometry and complex number, you can do all these things. So what is the third answer? All these answers are written here. Here you can find that if you look at odd entries and even entries, when I'm saying odd and even, it's basically order of the system. If your order of the system is odd, means you can see 0 also. So here C0 got 1, but let's forget about this C0. Let's start from here. This is second order, means even order has 2x square minus, let's assume that omega by omega 0 is x, because 1 times x0. Is it correct? If you look at this, this is only x raised to 1. If you are looking at this, it's 4x cube minus 3x. So in odd order, all odd entries are there. In even order, all even entries are there. Right? So these are considered as even entries, and odd entries will have odd things. Okay, so this was one observation. Now we may be interested in drawing Cn omega by omega 0 right, for different values of omega by omega naught, right? So what is going to happen at C0 omega by omega naught? This is always plus 1. So I can draw that it's for any value of omega and omega naught, it's always 1. If it is C1 omega by omega naught, which is equal to omega by omega naught, how the function will look like? It's a linear function, right? Can you see? So it's a linear function. Right? Now, what will happen if it is C2 omega by omega naught, which is equal to 2 omega by omega naught square minus 1. Right? So at parabola is like we can find out very easily. However, what is happening when omega by omega not equal to 0? It is equal. It's passing from minus 1 and will give me the effect look like this. Okay, yeah. We can find out these values also, right? So it's not with the scale, so you can find out, but that is not more important because these values are first and last values are more important. Now, what is happening? It is omega by omega naught is equal to 4 omega by omega naught cube minus 3 omega by omega naught. So this is 0, 0. And what else will happen? So how the nature of this plot will look like? Maybe you're right. So going in negative side to positive or from positive negative? Okay, so you mean to say the plot will look like, actually this has to be coinciding with this one. Is it correct or wrong? Wrong, right? No, this is not going to give you this. This way? Yeah, it has to be like this. Root 3 by 2. So it will go this way, right? Look like sine wave and go like this. Right? So in general, if you want to find out how many is it correct? When it's -1, what is happening? We should have drawn this. What if it is -1? If my omega by omega naught is equal to -1, what is the value? This is -1, so it's +3. This is -1, -4, so it's -1. It has to start from here, right? And when omega by omega naught equal to +1, what will be happening? It's +1, right? And at 0, it's 0. So if you this is wrong or right? This is right, right? And when it comes here, it has to go down and come back, because this third order, so 1, 2. At +1, oh. So this is correct? Okay. What about this one? +1 will have +1. It has to complete here, right? Yeah. Yeah. Right? There is actually a trick to find out whether your plot is correct or not. I know that trick, that's why I was looking at the trick only. So if you want to find out the order of the system by looking at this thing, before the last entry, this maximum and minimum starting from here will be the number of order. Means it's reaching the maximum and minimum value 3 times. Yeah, directly from poles also. No, by looking at this, if you have this response only, from response you can find out the poles and zeros. That's what I'm saying. Here there are 2, and for 4 you'll have one more maybe going up and down. So such a way you can find out these entries, and this is actually right now this is Cn omega by omega naught, which has been plotted for different value of omega by omega naught. However, we are interested in finding out what is happening to this entire function. Not only that, so that entire function where we are interested only in mod of this one, for that the maximum value is equal to 1. Maximum value is 1. You can also note that -1 is also become +1 in the case of mod, and the minimum value is becoming here 0, right? Okay, it has not been derived in this book, but so we have maximum and minimum values are already available to us, and we know that in passband, where we are interested in finding out So if we are interested in this, if it is first order, if it is zeroth order, then this will be plus 1, and 1 plus epsilon square will be the entry which is available here forever. If this is magnitude with respect to frequency, the first will look like this without any ripple. But in the case of first order, where it is omega by omega naught, for which we are seeing this kind of response. So here you are going to see this kind of response first order. It's a function, but right now we have derived only the function, Cn function. But in reality, when you are using in Chebyshev approximation, it becomes Cn square omega by omega naught because of the magnitude. So Cn square is not going below 0. All the negative entries also become plus. So that is what happening here, and that's why we wrote that if it is minimum, like if this function is minimum function, then this becomes 0 and you are going to have maximum value of this function. But when it is maximum, which is equal to 1, we are going to see this value is equal to 1 by under root of 1 plus epsilon square. So there is a band in between. The whole transfer function will actually give its own response. So this value, we can say that the maximum value is 1 and the minimum value is 1 plus 1 by under root of 1 plus epsilon square. If you want to find out in dB, it will become 0 dB, and here you can write down what? Minus 10 log 1 plus epsilon square, right? So that will give you all the required things, and if you feed all these entries of Cn omega by omega naught, you will see that the response will have such kind of entry. This response has been drawn generalized way, that's why it has been shown ripples in both the cases. Otherwise this is not with the approximation which has been given. Otherwise in stop band you should see the monotonous output only, you cannot have ripples. However, in the case of elliptic or basal filter, you can see such kind of things, right? So here pass band in terms of j omega is going to give you this function, and ripples are going to give you this function, right, which is already you can found out, right? And stop band, we know that Cn, so this was Cn square omega by omega naught. There were two different categories, one is pass band and one is stop band. Stop band has cos hyperbolic, so we have to just replace Cn omega by omega naught is equal to cos n cos inverse x when you are in pass band. When you are in stop band, this will be replaced with cos hyperbolic. So that has been kept here at the last, right? And again, like the solution of if you are solving these equations like we did it in Butterworth, this is also will take lots of mathematical calculation, but at the end whatever the solution you are going to see, the case for Butterworth where it was on unit circle, now this is on some ellipse. So that value you need to understand. I'm stopping this here because you can learn this in depth in DSP. If you are interested to go for DSP, DSP is full of all these derivations, mathematics. If you like complex number, if you like trigonometry, that will definitely like the course where you can perform very good, in my opinion, right? So I'm stopping here. If you wish, we can take one more lecture, or do you want or not? On Wednesday we have lecture, but today we have only 3 students, so I don't know. Maybe very quickly I can tell you one question. So I can ask similar kind of question. It might be useful to you. I don't know. I have not thought about any question. So yesterday we learned if you have some transfer function is given to you, anything, you can make circuit out of it using op amp. But that circuit needs lots of op amp. So rather than doing that, there is a small uh, previous thing which has been already derived by Selen and Key, which has been taught to you, or Thomas Taw. You can use these or biquad. All these people can give you second order low pass filters. This biquad is going to give you second order high pass, band pass, and notch if you use its configuration. So rather than going with that, if you know where the roots are, let's say something like, right? Sorry, is it correct or okay? So you can implement this part using any one of the configuration, and you can multiply next part with, if it is s plus alpha, how to implement that, by the way. If it is 1 by s, it's very easy. We have done it earlier time. This will give you 1 by RCS actually, minus 1 by RCS. So if I need 1 by s plus alpha, how to do that? So you can write down just 1 alpha by s plus alpha, s plus s by alpha plus 1. So what we can do, how to draw circuit. Right now, can you see it's lossy network? It's similar to what we have studied in lossy network. So of course you need this kind of network where you will have extra resistance in parallel of capacitor. But now what should be the values of these R and C? Can you find out those values? Hmm? So what will be this value? This value, this value. Oh, I took alpha outside. I didn't miss it. So if I take alpha outside, so it's 1 by alpha, s by alpha. Thank you. Right. So can you find out the values of R and C with some combination? Okay, I think that you can do it, but let's look at new circuit. Okay, I'm opening that Behzad Razavi, and there is chapter called op amp. If you want to learn it, because I learned one thing that you people could not learn, some diode circuits, clipping and clamping. You haven't learned. Unfortunately, I cannot teach clipping clamping, but I can teach something similar to that, but using op amp. Okay, so if this V in, so there are two kinds of diode. One is ideal diode and one is PN junction. So diode is the one where PN junction is the one when you need some, actually some potential or the cut-in voltage to make this on. So it might be 0.7 volt or some V on voltage. This book is following VD on, and in ideal case this VD on is 0. If anything you are applying more than 0 volt, this is short circuit and it will work. So can you draw what will be the output, by the way? If your input is sine wave going from 0 to plus 1, let's make it 2 volt, this is minus 2 volt, what will be the output? These are the questions asked in all the competitive exam, by the way. Let's consider that you are going to give this for some exam. You just draw. Look, it's, believe me, even after, like, even after having PhD, when I gave my interview, people ask me such questions in industry, you know. And believe me, even when I was giving interview to IIT Mandi, that expert asked me this diode question. So still it's easy, but sometimes people make mistake. And only in industry people are asking RLC circuit and just op amp. What do you say, Himanshu? Is it correct? If you are expert of RLC, diode and op amp, you can crack any interview, any analog interview without having any problem. Whether it's power electronics, TI, anything. So what is the output? Hmm? So you are taking this as, let's make, consider this one as ideal. If you have not done it ever, then so this is input, right, with respect to time, and this is voltage. So the output will be yes or no. Should run something else or same? Started from 0.7. Where? From where? Like from positive, it will from 0.7 volt. So have you drawn this one? If you have drawn this one, if you have drawn this one, then it's correct. The difference between everywhere, it has to be 0.7. Have you drawn this one? Hmm? After 0.7 volt, that gets short. Hmm? This is short circuit. Okay, I made a mistake. You are saying that this is the circuit. So I forgot that this is, there is on op amp also is there, right? So when this is short circuit, it's 0, right? So what have you drawn now? When it's 0.7 volt, this is 0.7. Till then, till 0.7, it's 0. Okay. But how it's same? You may be correct. So I have drawn same thing, no? Or something else. After 0.7 volt, okay. So after 0.7 volt, this current is flowing through this one, and at the output you can have the same thing. That is what you are saying, right? So in that case, it has to follow this one only. That's the correct one, right? This is what I thought. Okay, because of your reasoning, I thought I made mistake. This is correct, right? Yeah, but it has to be reverse. Minus. This is what you are drawing. Okay, and so maybe I can. Okay, some more circuit we can solve. By the way, such circuit, do you know the name of this circuit? This circuit is known as rectifier. This is rectifier. If I want to, okay, I can ask you one more question. So let's assume that there is some signal is going up and down. So I want to design a circuit which will detect all the positive entries only. If it is going maximum positive, you have to detect that. You can do that, but like just now we have made something where it is giving such output. Yeah, reverse of that means reverse bias diode, and at the output add a big capacitor with precision rectifier, right? Keep just big capacitor, right? So in positive and negative any side you can do that, and your output will look like this. So you have to take care of RC time constant, right? Okay, this might be okay. So just last and final question. Maybe like we discussed once, me and Piyush. So the question is as follow. Let's assume that you are having a water tank question. So from 0 to 100 feet, there is a water tank. I have 100 sensors are available, which I placed at every 1 feet, because hundreds are available, so I can place it at every 1 feet. So there are 100 sensors are there. Now I want to design a circuit using op amp which will convert this available 1 and 0 combination to a digital code. Are you following my question? So if you wish to do that, how you can do that? Like it's a tank and these sensors are already there. So if water level is increasing, if it is here, then all this 0, 1 feet, 2 feet and 3 feet sensor has to be on. Means it's equivalent to 1, 1, 1, 1 code. Others will be 0. By the way, if you look at this code, if let's say if it is filled till 80 feet, then first 80 will be on and rest 20 will be 0. Every time you are going to see that it will, like if it is starting from here, this will be 1, others will be 0. If it is till here, all 1 here and others are 0. You will never see a code where some of them are 0 and then 1 1 and then 0 0. It's not possible in such condition. By the way, such kind of code, it look like thermometer, so this is known as thermometric code. If you wish to convert such thermometric code to binary, you need a circuitry which is known as encoder, which is 2 raised to n cross n. So this n is binary and this 2 raised to n, whatever you are seeing, it's thermometric. So how to do that? You know the answer, so maybe you can try. Hmm? Using op amps. It's very simple circuit. When I'll tell you, it's very simple. I asked this question to Himanshu's examiner, right? It was for you or for your juniors? Right. No, no, it was in like we were solving in actually previous questions in IC161, me and Piyush. So this was one of the question. I don't know which batch I asked. I asked in final exam, and when I taught op amp. First of all, 100 levels will not help you. Look, it has to be 2 raised to n times n always, encoder. So you need actually 128, actually 28 are missing to implement 7 bits, right? If you are taking 2 raised to 6 means it's 64. So only 64 outputs you can see. Rest will be like useless. So you have to take for 7 bit 128 combination. Other 28 will be dummy. They are always 0, right? So afterwards, what you need to do? Aishwarya and what's the name? I forgot. Manas, yeah, Manas. So if I do such setup, look, this is maximum plus V supply, and this is minus V supply. Let's assume that plus V supply is equal to 100 feet and minus V supply is equal to 0 feet. If this is 15, this is minus 15, can you create by resistive divider network 100 different levels, right? So you will have V1 that will be equal to 30 because that is already given, 2 raised to n. Okay, you need 100, right? So 100, that's correct. So 0.3 volt is going to give you first 0.6, 0.9 and so on, and those are equivalent of these things. And if I am connecting with an op amp, there are series of op amps are available whose one of the input is the voltage created by you. It might be at minus or plus, and one of the input is the real input where like this label is coming, right? So this will give you these are the comparators, by the way. In open loop, either they will give you 0 or 1. If it is filled up till here, so 1 1 1 all 1, and thereafter 0 0 0, and thereafter you need one encoder circuit which will convert this to a binary. How was the question? Was that good? Like this was the what was the guy who was running that F1 race car, the F15? He made something, right, in Supra. Chaman, you know Chaman, who graduated. He made this in Aviskar using just op amps, without use of Arduino, without use of anything. He made it in half an hour and it worked.